Okay, so thank you for joining me. Apologies that I missed last week. We had some technical difficulties, a few new IT things happening here, so I couldn't do my video last week. So rather than try to do one of those in a hurry, I've done a little bit more planning than I normally do. You can see on my list what we're going to go through today, but pretty much the main point of today's video, it's a little bit longer, and it's not prescriptive in that I'm not going to show you exactly how to do something. I'm going to show you how I might think about doing something in terms of using the relimiter and the initial state and some of the new tools that have been introduced into Spry into what I would consider to be probably one of the better ways of dealing with the problem of initial state or pre-scheduling or updating your surfaces, or however you want to name that problem. It's often one that can take quite a lot of time. It can be a little bit error prone, and there's no brilliant way to automate it. I'm going to show you how I try to address the problem given the tools that I've got now available to me. So what we're going to do is, in summary, the basics are we're going to have a relimited solid, so a cut solid that is cut against the surface. But then we're going to use the normal initial state calculator tool to control our pre-schedule. We're also going to use solid colors and a spreadsheet to help us really wrap our head around what data, what volumes need to be changed, where we think the volumes need to be, what we've actually done, so that we can get a good picture of the workload that's involved in getting a good initial state done in Spry. So I hope that's clear. If not, it will become clear. Skip to the last couple of minutes of the video if you want to see the final results, but we're live at the moment, so you can't do that. So what we're going to start with is, if we need to do a relimiting, what we want to do is add a few fields to the database. Now, if you've previously done relimiting, you may already have some of this stuff set up, but what I'm going to do is I'm starting with the demo model. If I do have relimited stuff in here, I can't remember, but if I do have it, I'm going to add new stuff. Now, I don't have a relimited section, so I'm going to add relimiting. And I might actually drag it into my initial state folder, so we're kind of keeping it all together. It's related to initial state. And I'm going to add 4 fields. So I'm going to add solid. I'm going to add a volume. I'm going to add a percentage removed. And I'm going to add a percentage remaining. And then what I'm going to do is I'm going to do one of these for each of the solid types that I have in my model. Now, my demo model, you've probably seen 1,000 times. It has a waste solid and a coal solid. So I'm going to drag these in here. I'm going to reorder them a little bit. My volume is going to get summed. It's going to be handy to have that right. And these two are both going to be weight averaged on their volume. That'll do. They're going to be percentages as well, so I might change their format strings to be percentages. And then I'm going to copy that folder and create a coal folder. So I've now got one for each of my solid types. So with that in mind, I'm going to hit apply. There's a couple more things. I'm going to return to this table to do a little bit more later on. But for the time being, that's what we need to run the relimiter. So I'm going to go to my utilities, go to the Relimit Solids wizard, and I'm going to pick a surface that I hope I've got the correct one. I may need to go and grab it. I don't think I've actually imported the correct surface here in this version of the model. So let me just go ahead and grab that. So I think, just looking through a few files here, it will be an archive from a couple of days ago. This one here. Just drag, drop that into the screen. Alrighty. Oh, I do already have that triangulation. Perfect. Oh, yep, that is the one. Oh, I've turned on my arc ball because I was demonstrating something to somebody earlier. Probably don't want the arc ball, but that's okay. Alright, so I have the simplified version of the triangle that I want to do. Simplification is not necessary, and you might actually lose a tiny little bit of detail. It just speeds up the process for the purposes of this demo. If you haven't used the relimiter before, some of these settings are going to be it can be a little overwhelming. There's quite a lot of things happening here. The only thing that I would recommend you do is switching the clamps. We're going to change the defaults of these soon to be 1% and 99%. With the confidence factor in this tool has grown over time. So I'm not going to get into what they do, but what I am going to do is show you when we relimit. What we're going to do is we're not going to write to those fields. We're going to write to the new relimited fields. So we've got a relimited. We're relimiting the waste and coal solids. You can tell that I don't practice these. So we're going to write the volume to the volume field for the waste. For the coal, we're going to do the coal volume. For waste, we're going to do percentage remaining. We're going to do coal percentage remaining. Once you've done these once, these settings will get saved. So unless you're dancing between lots of different ways of relimiting, you won't have to go through this more than once. So we're going to go through set coal, coal, waste, waste, and then finally where the relimited solid is actually going to go. So we're going to cut the solid against the surface. This says export only modified solids. I'm actually going to untick that. I'm going to shoot through every solid, so even if it's not modified, it just saves me the effort of if a solid doesn't get touched by the relimiter, I'm just going to copy it down through. So untick that option. Everything else ticked on. This solid also only overlaps my Bravo pits, so just for the purposes of speeding things up, although we do some pretty good maths to stop it from being an issue, I'm only going to scan Bravo 1 and Bravo 2. Remove above, as in cut solids that are above the surface. We'll let that go through and relimit. Hopefully it should be pretty quick. So relimit, meaning cut solids. If you haven't used this tool before, and I've gone through this section a little quickly, there are some existing documents and videos on using the relimiting for dump solids, which go through things a little more slowly. But today's more about showing you some of the other tools to sort of combine with the relimiter so that you can get a feel for how you can combine these, not necessarily instinctively connected tools. So we've got a few solids here which didn't get successfully converted. That's fine. My solids in my model, this demo model, have been through the ringer, so they're probably not in the quality of state that most regular mining solids would be in. When I say that, they've gone through simplifications and testing and other things like that. So what we've got here is we've got a series of solids. Now, for the purposes of making sure that that's worked, oftentimes what I'll do is I'll have a separate case just to check that the relimit has worked, rather than using my existing case and butchering it with, solid colors and testing things. I'll create a new case that's just for source scheduling. I'll link it to my deposit table. And in here, I'll just be linking. I'm not even going to name the processes. I'm just going to link the volumes and the solids to make sure. There'll be a lot of gaps in this, but just to make sure that the solids themselves have been cut. And then I'll need a separate piece of equipment. Now, in a model that's been properly set up, this is less of an issue, but we're just going to jump in and have a look at the animation here. And so you can see, if I bring up, I'm going to turn this arc ball off. That is in the rotation mode. We don't set that one generally to anything other than normal setup. Go to plan view. There we go. Back to normal animation mode. Now you can see here, if we go and pull up the surface, that the new solids have been cut against it. Now there were some broken solids here. I would implore you to ignore these. These are because I have previously broken them through silly simplifications and other things like that. But we can work out ways to get rid of those anyway. But otherwise what you can see is I have this series of solids that you get this strange visual artifact, and that's because they are in the identical, they've been cut purely to the surface, so that's why we're getting those strange artifacts. So that's good. That means we've got successful cut from those relimited solids. So if I go back to my settings on my case, the next thing that I need to do is change a couple of extra settings. So on the initial state on the animation tab, my solid depletion mode, what I'm going to do is I'm going to turn on this solid depletion mode called ignore initial state. What this means is I'm going to use the solids that have come from the relimiter, and no matter what I set the initial state to, they're not going to be further depleted. So if I set it to 99% or 1% initial state, it's not going to get visually changed. So this ignore initial state allows me to use a new solid, but to otherwise play around with the initial state as much as I like. Hopefully that becomes clearer as we go through. So ignore initial state. Then in my processes, I'm going to change my solids to look at my relimited solids. So I'm going to set them a couple of times here, and then I'm going to use the bulk editor because I'm lazy and I don't want to do those drop downs over and over again. I'll just fire up my bulk editor and do a drag drop. And also, just for simplicity's sake, I'll grab some alternate solids fields. So just in case I've lost a solid, I can grab it from the other. So there's my new relimited solids. So if I fire back to the animation now, I'm going to get a bit of a strange behavior, and that's okay. So we're going to go reload solids, and we're going to get some solids that are depleted, and a whole bunch of them that have not been, which is, you know, what we're seeing here. We've got these relimited volumes. We've got a bunch of solids here that have got that are visible that don't otherwise need to be here. So that's sort of part one. That's getting the, sorry, we'll get this back in. That's getting the initial state and the animation solids based on the processes to be aligned. So that is in terms of where we were with this list of things to do. We're at stage 3, which is changing the case settings to reference the new solids. So we've done that, but there's a couple of other things that we might like to do. So if we pull up the original with the scanned surface that we did again, and we want to have a look at the available, sorry, I'm just trying to think of the words I want to use here, but if we have a look at getting rid of some of these extra solids, so if we go and have a look at that on the table, these are things that will have failed the solid simplification process, and you can see that that one there has come through with its original triangulation. If we go back to the solid, there's that 378 triangles, 378. The volume will be slightly different potentially, but that should be pretty much the same. And then the percentage remaining is set to 100%. So what we're going to do now is start to have a play around with how we can manage the initial state beyond this point. So if we go back to our animation, open up a second screen, we're going to pull open a second case settings to go to our initial state, because what we can do here is just start to add these to our list. Now I'm going to clear out my initial state, and I'm just going to put in a brand new 0%. So what this is, no initial state now, it's purely the original volumes. So the next thing I'm going to do is I'm just going to start showing you what happens if you 100% things out. So even though it says ignore the initial state for the solid state, it's not going to ignore anything that's 100% initial stated out, right? So you can tidy this up. I'm working on getting the initial state using animation up and running out of the beta. We've had that for a while in the beta, we just haven't cleaned it up. So you can click on these solids and get rid of them. But you can tidy these up pretty quickly. Alternatively, you could create a piece of equipment like in your relimit, in this case over here, and if you go to the path for that equipment and go to equipment path using animation, you can very quickly use the node select and start, in order for it to start removing solids, you need to have it produce a successful schedule run. But once I can do that, I can just start adding things to the path a lot more quickly, so I can tidy it up. So a little step that I skipped there, I needed to make the schedule run once so that it was smart enough to understand what was getting removed from the front end of the schedule. So I'm just coming through and tidying these up a little bit. Anything that clearly shouldn't be there. And so I don't know why I'm getting a double space down here either. We need to have a look at that. But if I grab that list, throw it over in here, what I'm going to do is I'm going to put in a region called tidy up. Now I'm typing out the terms region because I come from a world where it wasn't an option, but the other thing that you can do is you can select these and choose surround with region. Okay, so I've got my tidy up. I know I'm going through this quite quickly. If you want me to go through this process with you, if there's anything that's not super clear, please let me know. But I'm going to hit apply now, and I've pretty much got everything. I've missed a couple. There's a slight difference with the relimited volumes. So I'll come through and just tidy up these last couple. So this is the first part of the process, which is just if you've got dodgy, like really bad solids like I do, you may be in a situation where you need to do more tidying up than your average. But most people, if your solids have come directly from Vulkan or Deswik, Minix, and to a lesser extent Mindscape, it depends on how you've gotten your Mindscape solids, then you shouldn't have to do any of this. This is just because of some legacy from old playing around that I've done. So we'll tidy up this last one and pretend that it's been done properly. And so what we've got now is a series of solids, but what we're missing here are the volumes being changed. So right now, visually, a lot of these solids have been adjusted, but they haven't actually had their volumes changed yet. That is a really important thing to note. So visually, they've changed, but volumetrically, they haven't. So if I hover on one of these very small solids over here, I might just turn this solid off to help me get volumes. I've still got a full, in this example, 23,000 cubes, even though the solid itself is now much, much smaller than it started out as. And so what I'm going to do is I'm going to show you a few ways to use some solid colors to tell the difference between, to see which solids have been changed a lot, which ones haven't been. So again, this is the part of the video I wanted to get into more detail with. So there's a few concepts here to have a think about, which is that the volume on each of these blocks has been changed, but the visuals, they've been changed, but we haven't really updated those numbers in the background yet. And we can use initial state to do that. But if we look at this record individually, I'm just going to focus on one record at a time to keep it, to try and keep it as simple as possible. So we'll take that record there, which has got some coal and some waste in it. And we're also going to, for the purposes, I probably should have pulled up the original solid too. So I'm just going to grab that original solid. I'm going to spit it out to a folder here. And I'm just going to drag it back in so you can see it on the animation. There we go. So there was the original, and there's the new one. I should be able to set some transparency on this too to help you visualize. Okay, so original solid, which had the full 23,000 in it. I'm going to set its design visibility to not selectable so that I don't have to worry about right-clicking on it. Okay, so hover on it now, 44,000 cubes in there, but that is based on the original large, effectively block cookie cutter solid. But clearly it's now much smaller. So I'm going to give you a few tips on how I like to manage this. Okay, so on the table we have the percentage removed, percentage remaining. So we actually have, for this particular record, and let's, for the purposes of this, to try and reduce some of the visual confusion on screen, I'm just going to clean out a few of these solids, a few of these bits of information. So we'll keep our imported information, we'll keep some scheduling information, and we'll keep our initial state, but everything else can disappear. Okay, so originally what we had was 44,000 cubes. That ended up being 44,000 excavator cubes, but now what we've got here is what we think is about 9,000 cubes left. Now, there's a couple of different things you can choose to do here. The simplest method, if you're in an excavator only environment where you don't have to deal with concepts like cast, dozer push, spoil, there's a pretty easy way to help you get your initial state done from this point onwards. And the way to do that, if you go into your fields, these two percentage removed or percentage remaining fields can actually be used as your initial state. So something that has a 0% removed, so we want to use percentage removed here. Now the challenge is we only allow you to access percentage type fields. So what we're going to do here is we're going to rerun, because I probably should have done this in the first place. We can either rerun the relimiter with a new percentage removed, or we can just duplicate the value, which, yeah, in retrospect, I probably would have set that to be a percentage type, but I can use a calculated field to do the same. So I'm just going to grab the value of that one and effectively convert it into a type that I can use for the initial state, initial value. And so what this is, do it this way, so coal to coal and waste to waste. What we're going to use this for is, if you've previously, and if you've been around Spry for a while, you might have used the initial state calculator, and that got used in a scanning way, similar to the relimiter, but it didn't produce a new solid for you. Now what we do with the, go all the way down to the bottom, that one there. So now what we're going to do is use that same percentage for our waste, and our coal is done. And let me explain what that's actually doing. So if I remove this line here, which writes everything back to 0%, this here, the way, if you're not familiar with the initial state calculator and the initial state, initial value fields, they kind of occur on this hidden line 0. So there's line 0 has all of these numbers that are in here getting written back to topsoil free dig. And then what we do is we start at line 1, and you are overriding the behavior of the initial state, initial value fields. So what we do then is we, so by having this, if the normal default initial state path has this 0% at the top, what that does is effectively doesn't use any of these numbers. But if we don't have that line in there, and we just focus on this one record, what we're going to be using is that 77%. It is exactly the same as writing, and I'm not using the decimal places because I'm lazy. It's exactly the same as writing this, but invisibly above the point, and doing it for every record that was touched by the relimiter. So what that's giving us, if we hit apply on that with those new values in here, and we go back to the animation, if we hover on that solid now, you can see our quantity has changed. So we hadn't done anything, we were at 44,000, we're now down to that 9,000 mark. We're using the percentage that the relimiter gave us for both the waste and the coal. Now the coal wasn't touched by the relimiter in this example, so it hasn't been changed. That 22%, 22% remaining of the original, so there's something like 77%, 78% of it is gone. So that works well if, once again, you don't have to think about spoil, or you might want to use this as your starting point, but then force yourself to tidy things up. So this is where we're going to get into a little bit more of the detail. So what we're going to do here is create a series of solid colors, firstly, to help us understand the blocks and how much they've been, the relimiter assumes that the value should be. So I'm going to create a table field value style, and we're going to throw in percentage removed. And you'll see this, a lot of them are 100%. Those are the ones that were totally above the surface. And then you've got this kind of wide variety of things. And if we say include zeros, looks like we actually touched pretty much all the solids. This is a pretty aggressive surface. But we hit accept. We now have a wide variety of percentages. You can make it fewer bits of detail. But if I go through and apply a color palette of red to green, and I will just unlimit my range again, this will kind of show you which blocks have been touched the most versus touch the least. I think it probably makes more sense to do the colors around the other way. So right now we're saying only 1% gets red. We probably want to do that around the other way. So let's switch them around so that red is telling you these colors are the ones that you want to pay attention to. There we go. All right, so the red ones, there's been a lot of change. The green ones, there's been less change. The gray ones, there's been no change at all. So anything, it's it's not quite made clear here, but we've got a between here, and the between make sure that it will only show you if something's been removed. If nothing got touched, there's nothing to say 0% in here. So the earliest one, it's actually 0. So if I just make that 0, or I add a new record and drag it to the top. So unfortunately, I don't have access to the index here, so I'm going to tap on this 100 times to push it to the top. It's one of those things that helps you realize that you need to add features to the software. But if I pull that all the way up to the top, anything, oh, I need to set that to be less than 0.01. So that value is between 0 and 0.01. There is actually an option in the wizard to include zeros, which is what I should have done. The whole point of that was to have a separate color for the solids that are not touched by the relimiter. Once again, I'm more just trying to show you some of the ideas on how to keep track of this. So this is a pretty basic one. Solid colors to just show you whether or not the solids are within the spec of what you expect. Now, what we're going to do now is we're going to do something a little bit more advanced. And this is just to give you some ideas about how you can understand how to do initial state as smoothly as possible. So right now in the relimiting section, I'm going to add some more. I'm going to add some more detail, and what I'm going to do is I'm going to chuck in a folder called audit. And what I mean by audit is I'm going to use some tricks to determine how much scheduling volume is actually going to be in the model. And how I'm going to do that is I'm going to copy my scheduling folder, and it's a lot of information, but I'm going to clean out a lot of it. And what I'm going to do is I'm going to grab all of the things that I don't care about. I might leave drilling in there. I'm just going to focus on excavator, but all the rest of these would apply as well. And what I'm going to do is with this field, and I've got prime volume, I don't have any rehandle in this model. But what I'm going to do with this one is I'm going to take the scheduling, the normal source quantity field for excavator, which is my scheduling or scheduled prime volume for excavator, and I'm going to multiply it by the inverse of the initial state. And what I mean by that is we've got in here, take out, oh, it's got the word prime in there, that's why I was seeing all primes. I don't know when I did that. Anyway, multiply that by the 1 minus the excavator's initial state. And so what that's going to give me is a volume that I can compare to what the initial state calculator thinks is the volume. So I'm going to put in another field next to it called variance. And I'm going to make that a calculated field that compares what that excavator value is. So I'm going to take the excavator prime. I'm going to divide it by what the relimiter thought it was supposed to do. So the relimiter would, and this assumes that the relimiter, actually it's probably safer, so let's not do it that way. Let's use that's the prime volume. Let's just compare the initial state values. So let's actually not do volume. Oh, that's my mobile phone. I'm just going to pop you guys on hold for a second while I answer my phone. Thank you for your patience. That's a problem with doing things live. Okay, so let's go with variance. So we're just going to compare the initial state to what the relimiter thinks should be the initial state. So let's change this. And this is, once again, this is I'm trying to show you how my process how I go through this process as well. And some of these tools are quite new. So we're going to compare excavator. We'll call it excavator variance. we will make it a calculated field that compares the initial state, which is this one. We're going to compare that value to the percentage initial state compared to the percentage removed. So I'm just trying to think about which value is the one I want to compare it to. So percentage removed. So if I've got 100% initial state, I've 100% removed it. So I'm going to have those two things divide into each other. I'm going to give them a format of percentage. And I'm going to, hopefully, this will give you an idea on weight average that by imported volume is fine for the time being. I want to inspire, or inspire is a bit of a lofty term, but give you some ideas on how to think about it. So if I go back to my, I need to make sure that that number is not 0, because I'm going to be getting some, I should be doing a safe divide, not a regular divide. So safe divide. So safe divide of the initial state and what the relimiter thinks the initial state is. Now this should be essentially 100%, or it should be perfect. Should be 0%, right? So there's no actually percentage removed. Yep. 77. That should be a 1. What mistake have I made in my calculation here? Get value initial state divide. Oh, I've picked coal. I picked the wrong field. This is why you want to start with a single value where you know the answer as well. As a side note, if you try to do this without focusing on a single record where you know how the answers are going to play out, you can get stuck and be like, why am I getting wrong numbers? So here we go. So I'm expecting 100%. I've gotten 100%. Now, let's say in this example, so I'm using that number. They should be identical, right? So I am actually using the initial state percentage removed to get me to my initial state for my excavator. But if I wasn't to do that, if I turn this back on to 0% and don't use, but this will mean I'm not using the initial state initial value field, I'm going to get a variance in here. Now, right now, the variance is going to be 0. I'm going to be 0 divided by this. I probably need to tidy up my maths a little bit. Probably need to throw a -1 in there. Yeah. So you've probably got some better maths, right, for this, but what we're trying to point out is that these numbers are not, we're not kind of thinking they're in the same place. So if I take that value there and go, look, I know for a fact that I have removed, let's say 30,000 tons out of there. So, sorry, 30,000 cubes. I started with 44,000. I know that I've moved 30,000 out of that area. If I hit apply, what you'll get is I've got an initial state of 67%. The scanner thinks I got 78%, so I've got an excavator variance in here, and it's saying that I've got more waste here than the relimiter thinks I should have, and this presents another opportunity for us to color our solids and to do a few other things. So I'm going to create a new solid color set. I'm going to do this one. I'm going to do this one manually to show you an example. So I'm going to take that variance. And you might want to set up a few different versions of this variance. But I'm going to say if this variance is less than -0.1, so more than 10%, I'm going to make it a shade of blue. I'm going to create another one of these. Now, if you're not familiar with how these work, whichever thing it hits first, it's going to stop at. So if I make a 0.1 and a 0.2, I need to make sure that whichever thing is going to be the less likely to happen sits at the top, right? So that the next item filters through down. And then I'll create a couple more where I say greater than 10 and greater than 20. Now, how much you actually care about is going to be up to you, but we'll go with bright green down to a duller green. And so this record that I've been focusing on, there's a lot of records here which are bright blue, which if I haven't named them very well, but that's because I haven't done initial state for them, and so their variance is going to be minus 100%, right? So they're going to be wrong by a decent clip. But this one that I have been focused on, as I start to play around with this number, what you're going to find is it changes. So the initial state colors will update as you go. It's going to be a live, up-to-date visual on how close you are to being within the scope. So if you make this, if we go to 77%, right, which is, we know that the number is 77% here, but we're going to get our normal boring, well, oh sorry, I wrote 0.77% because I'm not paying attention. I go back to the animation, I get my normal boring grey color, which you might want to set to be a green or something like that, but that's telling me that I am within what the relimiter expects, right? And so I can manually control the volumes in these areas and get some immediate feedback visually. That's a way of doing visual feedback. The last 10 minutes of the video, I know I'm keeping you for a long time and I'm rambling a little bit, I apologize, but once again, it's about giving you some ideas for initial state, which can take a bit of thought to get to the state where you want them. But if we go to a spreadsheet, what I want to do is show you how you can use a spreadsheet to do something similar, but give you some more interesting information potentially. So with this, what we can do is we'll take the same approach with a spreadsheet, but we can use table values to read some of these numbers off the table. So what I'm going to do is I'm going to show you a table value that reads the whole lot of records off the table and how much percentage has been removed. So I'm just going to go table value. I'm going to pick my deposit table. I'm going to pick the field of relimited volume. I'm going to pick the range. So I'm just going to actually I'm just going to leave the range blank actually, and I'm going to pick the top node. Now I know that it doesn't include alpha, but I'm just going to go deposit. I might actually create a range for Bravo, just in case I don't have one. In my model there's a Bravo 1 and a Bravo 2. This is not important. So what I'll get out of that, and if I format it a little bit more nicely with some 1,000 separators and no decimal places. I've got 9 million. It's exactly the same as what I would see if I went to the top of the table view. But what this is going to allow me to do is I can start putting in a few different volumes in a few different areas and start to compare my scheduling volumes to my initial state volumes. So if I throw in, and I did it earlier with this excavator variance, I'm going to throw in excavator scheduling volume, which is what I was getting to before. I might have to do up a document that tidies up some of this thought process. But if we take our initial state for our excavator and multiply it by our prime, well, it's 1 minus, just as a trick, because 100% removed means you'll have 0 of your prime. So I'm going to use that there as my scheduling volume, and I'm going to do the same. I'm going to do the same thing here, but I'm going to change the field that it references. So what we can do is, if we right click here, we can copy this field name, go back to our spreadsheet. I'll try that again. Copy field name to clipboard. Paste. Paste. Is that an issue with my copy or an issue with my paste? It's an issue with my paste. Oh, I need to click into the cell to paste it. That's a minor annoyance that I'll have to chase up. Clicking into the cell if you're pasting in with text that's on the clipboard for some reason. But what we can do is we can change that reference here. Point it at that cell. Let's lock the A, but let's lock the 3, but not the A. Other way around. Let's lock the A, but not the 3. You can see I've got 26 million in here in the Bravo range and excavator scheduling volume. But what I can start to do is control how much volume, that's how much volume I currently think I have. If I apply my initial state calculator, hit apply, I will need to hit recalculate in the spreadsheet. It's not smart enough. The animation is smart enough to know that the values will have changed, but this is not. So if I hit calculate now what I'm done is I'm pulled down to 8,566,000. So I've got less volume here in a scheduling space for my excavator than I thought. Now that's not going to surprise me, in that if I go up to the top of Bravo 1 and Bravo 2, there will also be some free dig and some topsoil. So I need to do the same fields for my free dig and topsoil, which is all I'm just going to quickly add these in. Volume and free dig. Volume, replace the word excavator with, you can control H in here, if you excavator with free dig. We'll just, whoops, might help if I could spell free dig. This is actually meant to be my topsoil one anyway. That's what happens when I try to do things too quickly. Initial state topsoil and initial state free dig. Initial state free dig. Alright. So we've now got free dig, initial state, and excavator, and we'll let that apply. It's taking a tiny little bit longer than I would have hoped. I am in the normal release. Yeah, okay. There's a couple of bugs which have actually already been fixed in the beta that are popping up here. We can ignore that one because we can now see, if we scroll down, we've got some topsoil and some free dig, and if we take all three of those and add them up, I would expect us to be pretty close to that 9,200,000. So we're going to take these fields, we're going to change this to topsoil. I must have not quite spelt that right. Free dig. What did I call them? Probably free dig volume, not free dig scheduling volume. Yeah. Inconsistent, but and if I sum those three things up, I would expect to be, if not identical, pretty close. Sum, why did that not work? Equals sum of those. Pretty close, right? And that's what I would expect. There may be a very small amount of volume that I've manually removed from the tidy up. If I take out the tidy up, I would imagine that these numbers will be pretty close. So comment, apply, and then recalculate. Yep. So some of them are not caught by the scanner. As I said, my solids are not great here. So we'll take that, to put them back in, and from here what we're going to do, and this is hopefully where you get a little bit of interesting information, is if we start to take these ranges and simplify them down to let's say seams or blocks or strips, so we can use the same. So right now if we insert another, so this is going to be the field that we're reading, we can also throw in a range, we can also throw in a parent node. So right now the range we're using here is called Bravo, so instead of using actually that's the range that we're using, so instead of that we can pop it referenced to there by locking the B and not the 3, type the word Bravo in there, and so if we drag that down, you're starting to see, hopefully, whoops, insert, there we go. We'll throw in another couple here, insert, so we'll go with table, drag that down. And then what you can start to do in here is you can throw in what that one in there would be expected relimited volume. We might call this relimited volume. And we can start to play around with percentages of what we expect to have in that area. So if I expect to have, let's say right now, I've got 9 million cubes in there based on the current layout. Now if I wanted to just arbitrarily remove from certain areas some volumes, what I can start to do is throw in the values that I expect to have. So I expect to have 8,500,000 cubes. Is that the comparative difference between that and this is going to give me some interesting information. So if I take that and go that divided by that, I get 92%. So that there, what I can start to do is use that information to find records that I want to deplete information from until this number gets me to 100%. So I might, yeah, and you can see there's these tidy up ones need to go in. So I might expect, I know there's my, I've got my scan here, right? But let's say, oh, I've got this one. So it's a little hard to do on a screen as small as this one, but I'm going to try. But what I can do is as I start to add things and say, yeah, look, that's gone, I hit apply now. I then hit recalculate on my spreadsheet. I can start to get this number. Oh, you can actually see that was a little unintentional how much of a difference that one actually made. But you can see now when I go, look, I'm actually expecting to have 8,500,000. I remove that one record. I'm going to pull it back in to drive home the point. Reload the, recalculate the sheet. Oh, I mustn't have hooked up. I mustn't have hit recalculate after making my changes. That's probably what it was. Yeah, that'll be what it was. So I'm expecting to be 850. That's what I'm actually at. But let's say I wanted to make that 8,400,000. So I'm at 98% of what I expect to be at. And I can just start jumping in here. I can look at how much I expect to be removing from it. This what you can also get this to tell you how much volume you have left. So if we go 1 minus that multiplied by that, and we'll format that number 1,000 separator. Once again, I'm really hoping that you're pulling the interesting and useful things out of this and not just exactly what I'm trying to do, because it's a little bit chaotic. But if I start to remove a few records from here, and I might start make a look, I actually we've done a little bit of work out of here as well, so I might just get that solid out of the way. I might just start taking stuff out of Bravo strip 10, Bravo strip 9. I start hitting apply, I start hitting recalculate. Oh, I need to hit apply, recalculate. We can also do things to hook up the spreadsheet so that when you hit apply, it recalculates the spreadsheet. Go back to formulas, hit calculate. Oh, it's just that those have very, very small volumes in them. But we can start to pull, if we pull some of these bigger blocks in. Calculate. You can see I'm starting to pull this number back. I've got 110,000 cubes to remove from somewhere else. And so I know this has been a little bit more chaotic than I'd hoped, but we're at almost an hour. I may be revisiting this with a little bit more care. I thought I had a good idea about exactly what I wanted to do, but I'm learning as I go. But hopefully what you can see is the combination of initial state, solid colors, relimiting, the new options, which specifically the ones that are the most helpful for this new process are the animation option to ignore the initial state, as well as the ability in a table value to go to the absolute top of the table and read all the information on the table, is you can construct a spreadsheet given a little bit of care that allows you to be in really tight control of how much volume you have, how much volume you expect, I imagine some of you guys that actually have to do this work have already got some things that are either wrong with what I'm doing, or ideas about how you could do it better. I'm keen to see what you're working on. If you have any questions or you run into issues implementing this, I'm much better under the example of something that you're actually trying to do than I am in just making stuff up on my demo model. I hope that's added some value. Thank you if you've managed to stick around through all of that. And yeah, have a good weekend. Thank you for your patience. And yeah, if you want a more personalized approach to some of the stuff that's happening in this, just give me a buzz. Shoot us an email, support@precisionmining.com. Give us a call, 3539 0000. Have a great weekend and see you next